we're going to Google BioInterface humans. A biointerface in humans is a crucial boundary where synthetic materials meet living biological systems, cells, tissues, blood, vital for medical devices like implants, sensors, and drug delivery, aiming to control interactions like cell adhesion or clotting for better health outcomes, often involving advanced materials engineering and biology to create seamless, functional connections for monitoring and therapy. A biointerface is the region of contact between a biomolecule, cell, biological tissue, or living organism or organic material. Let's click on the images. Here is a lovely image from ResearchGate. Networked Biointerface Challenges. Networked biointerface challenges, graphically visualized and stated in 3 broad categories. In material and interface challenges, we have biointerface, sensors, stimulators, and encapsulation. In integrating challenges, we have energy, material system, communication, and computation. In adoption challenges, we have user acceptance, commercial viability, regulatory hurdles, and continued use. Let's go over here to Science Direct, and we're going to read. Engineering the drug carrier biointerface to overcome biological barriers to drug delivery. When we search biointerface humans on Google, the first thing that it says is that it's being used for drug delivery. Micro and nanoscale drug carriers must navigate through a plethora of dynamic biological systems prior to reaching their tissue and disease targets. The biological obstacles to drug delivery come in many forms and include tissue barriers, mucus, and bacterial biofilm hydrogels, the immune system, and cellular uptake and intracellular trafficking. The biointerface of drug carriers influence how these carriers navigate and overcome biological barriers for successful drug delivery. In this review, we examine how key material design perimeters lead to dynamic biointerfaces and improved drug delivery across biological barriers. We provide a brief overview of approaches used to engineer key physiochemical properties of drug carriers, such as morphology, surface chemistry, and topography, as well as the development of dynamic response materials for barrier navigation. We then discuss essential biological barriers and how biointerface engineering can enable drug carriers to better navigate and overcome these barriers to drug delivery. And if we look at this lovely image, here we have tissue barriers, biological hydrogels, cellular trafficking, and immune system. Here we have topography, surface chemistry, morphology, and dynamic materials. Let's go back to our Google search and click on another image. Human-machine interactions with neuromorphic nanoionic devices. Ionic activity is the fundamental process in biological synapses, neurons, and neural networks, forming the basis of neural information processing and enabling cognitive functionalities in biological nervous systems. Inspired by the ionic behaviors in biological systems, neuromorphic nanoionics explore ionic migration and transportation in memristive devices for AI systems to resemble the architecture and principle of biological neural systems, ambitiously aiming at cognitive information processing towards efficient and intuitive human-machine interactions. They are watching all of this for your future values. They are watching all of this for the software-defined metamaterials. They are watching all of this to resurface any cell structure they need to in vivo, in situ, in real time. We're talking about the ability to not only resurface any cell that you have body-wide, but also how it moves through your limbic system. Let's go back to Google and search limbic system. We're going to click on this link. The limbic system is the part of the brain involved in our behavioral and emotional responses, especially when it comes to behaviors we need for survival, feeding, reproduction, and caring for our young, and our fight and flight responses. Now let's go back. Short-term memory, long-term memory, processing in the air molecules around you. And then the artificial neural networks that it harnesses with deep learning using the same wireless that's all around you to store data is your cognitive computing and your ubiquitous computing.